Hello, welcome to the graphing video with Mrs. Lehnert at High School for Hospitality Management. Today you are going to need your notebook, your input page for the graphing notes, a pen or a pencil, and a calculator. Our learning objectives today are that the student will be able to create accurate scales for graphs. The student will be able to graph data accurately, and the student will be able to interpret graphed data. So let's get started. All right, so the basics. We all know what a graph is, hopefully. It's just a visual display of information or data. And we are going to be talking about 3 different graphs today: line graphs, bar graphs, and pie graphs. So we're going to start off with line graphs today. Line graphs show trends, or if you're not sure what that word trend means, that means how the data changes over time. So for example, when both sets of data are the numbers. So for example, in this graph, we see that at the bottom there are numbers, dates in this case, and on the side label, which is the y-axis, there are numbers. So that's a really good indication that we should be using a line graph instead of, say, a bar graph. So what is a bar graph? Bar graphs are used when the data on the x-axis, that's the axis on the bottom, those are not numbers. For example, they could be planets, they could be names, they could be colors, as in the graph that we have here. Basically, anytime the data on the x-axis is not a number, you can bet it's probably going to be a bar graph. It could also be a pie graph, but if you're trying to decide between using a bar or a line graph, good indication, if they're not both numbers, that it's probably going to be a bar graph. And our last type of graph is a pie graph. So we don't use these very much in earth science, but occasionally we do. And these are used when you want to compare portions of a whole. So for example, when all of the values add up to 100%, then it's really kind of helpful to know, well, how much of that 100% is this? For example, in the little pie chart at the bottom left, what percentage is children, what percentage is women, what percentage is men, or the one on the right, how much water do we use? It's kind of helpful to kind of visualize, oh yeah, I can see right away that using, for example, the toilet and the clothes dryer or clothes washer are going to take up the most of that pie. So remember, if this video is going too fast for you, you can feel free to pause, go back. You can't skip forward in these videos on Edpuzzle, but you can pause and go back and repeat things. So the first step in creating a scale is to count the number of lines on the axis. And we're just going to deal with the y-axis, which is this one. The x-axis is the one on the bottom. The way I remember that the x-axis is down there, the x is low, the y is high. And it kind of rhymes, so that might help you to keep the distinction between the x and the y-axis. So when we count the number of lines on this y-axis, we are not counting the bottom line. So we are not counting that one. We're going to start with the very next one up. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that gives me 12 lines. The second step is to subtract the highest value minus the lowest value, and then divide by the number of lines on the graph, the 12 lines we just counted. And then you're going to need to round up to find the scale to use. So let's try this with an example. So we already said that the number of lines was 12 on the y-axis. The highest value in this data table, this is a data table, we have different months and we have average rain in inches. The highest value looks like it's right here, April. with 175. And our lowest value looks like it is 53, which occurred in March. So my step number 2 was to subtract the highest value minus the lowest value. So I'm going to subtract 175 minus 53. 5 minus 3 is 2. 7 minus 5 is 2. 1 minus 0 is 1. If you needed a calculator for that, that's fine, because you actually get a calculator in class when we do these. You get a calculator on the Regents exam, so don't feel bad if you needed to use a calculator. And then our next step is, the second part of that step 2, is to divide by the number of lines on the graph. So I'm going to divide that by 12. And when I divide that by 12 with my calculator, 122 divided by 12, that equals 10.17. So hopefully you did that on your own, so that way you can double check my math. Now, because it's a little bit higher than 10, we can't use 10. In other words, what we're trying to figure out here is how much can we go up by. And so if we start off on that bottom axis, and I'm zooming in a little bit here so that you can see, if I start on this bottom axis with the lowest number, and the lowest number we said was 53, if I went up by tens, I'm not going to make it to the highest value of 175. I'm going to be short. So that means that I need to round up. Now, on a graph, it seems weird. If you can't go up by tens, you're not going to go up by 11s. And you're probably not going to go up by 12. That's just a weird number to increase by. So usually scientists will go up by 15s, and even that is a little bit weird. And so usually if they can't go up by 10s, you'll go up to the next, I guess, roundish number. So maybe we can try 20, okay? Now, if we're going to round up that much, we can probably, instead of starting with our lowest value of 53, we can probably go down a little bit farther. And so what I'm going to do is I'm going to start this bottom line right here at 50. Okay? And so if I start at 50, and I'm going to try to go up by 20. So each line is going to go up by 20, which means this next line is going to be 50 plus 20, which is going to be 70. So go ahead and pause the video, label your graph, use a pencil if you're not sure if you're going to get it right, and then start the video back up again, and you can see if you did it correctly. Okay. So this is what your graph should look like if you went up by 20s. You should have ended up not all the way at the top. You didn't have to go all the way to the top because we only needed to get up to 175. If you went all the way to the top, that is fine. Just realize that in the future, to save yourself some time, you only have to label it until you get just above the last data. Okay. So now that we've got our scale created, you should be able to graph this data. And you need to figure out, okay, I know it's not going to be a pie graph because it's not in the shape of a circle. So it's got to be either a bar graph or a line graph. Which one is it, and why do you think so? Go ahead and take a moment to figure that out. If you said bar graph, you were correct. And the reason that it is a bar graph and not a line graph is because the month names are at the bottom. They are not numbers. Now, I realize that we could have put them as month numbers, and so it would have been 3, 4, 5, 6, and 7, because those are the different month numbers if you were to put them in order. So I suppose if you said line graph, that would be fine too, but in this case, since they are names, we would probably use a bar graph for this. So now, I want you to pause the video and create your graph of the average rain for each month, and then you can start the video up again so that you can check your work. Remember that you're making a bar graph, and so each bar should be right above each name of each month. Okay, so this is what your graph should look like. I like to leave a little bit of space between each of the bars, and hopefully you did that as well. If yours doesn't look quite like this, go ahead and fix it. Take some time, pause the video, fix yours, make sure that it looks like this. Okay, so now's your chance to check your understanding. Would you create a line graph or a bar graph for this data? The question is going to pop up on your screen. Go ahead and click the correct answer, and make sure you click continue to continue with the rest of this video. Okay, hopefully you got that one. This one is a bit confusing because there's a lot of data here. Would you create a line graph or a bar graph for this data? Okay, so hopefully you figured out that one. This one is a little bit confusing because there is a lot of data. If you look at the title, it says the number of moths by year. So the numbers across the top, 1800, 1850, 1875, those are the years. Those would go on the x-axis at the bottom. And so what would go on the y-axis, the side? That would be the number of moths. So the 100, 97, 90, 0, 3, and 10, the numbers that are underneath the years. But there are light and dark moths. So you would first graph all of the light moth numbers, 100, 97, 90 for each of the years, and then you would connect them with a line. And then you would graph all the dark moth numbers, and you would connect them with a different colored line. So you'd have two lines on your line graph. Hopefully you figured that one out. All right, get ready for your next question. So for this one, we're using the same data. And in this case, I want you to figure out which graph represents the data from the table. So take a look at those different graphs, and then when it pops up on your screen, click A, B, C, or D to choose the graph that you think matches that data. And again, don't forget to click continue to listen to the rest of this video. Okay, so if you had ruled out choices C and D, so in other words, if you chose A or B, both of those are really great choices. So you ruled out C and D, which is great. Graphs A and B show the numbers of light moths decreasing and dark moths increasing, which is exactly what's happening in the data table. But if you look a little bit closer at the dark moth data, you see that it goes up from, for example, 0 to 3, right there, and then it increases, which is not a big increase. From 0 to 3, not a big increase, but then it increases from 3 to 10, a little bit bigger of an increase, because that's going up by 7. And then here it makes a big jump. It goes from 10 to 35, and then again from 35 to 79, another big jump. And then from 79 to 90, not as big of a jump, right? That's only going up by 11. And then from 90 to 93, that's only going up by 3. So it starts off increasing slowly, and then it ends up increasing slowly with big increases in the middle, and then it increases slowly again at the end. So that is what is happening here in graph A. Increases slowly, big increase, and then it tapers off with a short, like a small increase at the end. And then you can see, you can kind of do a double check. Same kind of thing is happening with the light moss, except it's decreasing. Starts off decreasing kind of slowly, and then really speeds up and it's decreasing, and then it slows off again at the end. And so that's how we know that graph A must be the correct one. And that's it. Great job. So now you just need to answer that last question, and remember to bring your notebook to class tomorrow to get a stamp. Again, answer the last question, make sure you click continue so that way you get credit for watching the whole video. All right, see you tomorrow.